Everyone, so today I'm going to teach you how we can solve the our simply supported beam and draw bending moment and shear force diagram for the beam using Python programming language. The problem we are going to tackle today is as shown in this figure, where there is a in support at the left side and roller support at the right side, and there is a 10 kN load acting upon the beam at 1 meter from the left side and 3 meter from the right side. So we know that this is a simple problem, and the bending moment diagram will look as follows, where the maximum bending moment occurs at the point where the load is acting. Similarly, the shear force diagram also looks similar to as shown in the figure below. And to solve this problem using Python programming, we need to understand the mathematics about of how we are gonna solve it. There are multiple ways we could obtain the solution, but but today we are going to solve. I'm going to explain how we are going to solve it. So first of all, let's draw the free body diagram of this beam. We have this R1 and R2 reaction force, and we have this 10 kN load. And let's say this 10 kN load is a P load. We just represent it with a P, and the distance is represented by A and B. So what we need to do is calculate. First, we need to calculate R1 and R2, and in order to calculate that, we have a formula, that is R1 equals to B by L, where L is equals to A plus B, and that is the span of the beam B by A into P. And similarly, R2 is given by this equation, A by L into P. And after calculating uh, this, we need to calculate the BMD at point P. So for that, which is given as bending moment is equals to R1 into A, or also this is also R2 into A into B, which can also calculate using R2 equation. This is B. Similarly, what then we need to calculate shear force at P, and this can be calculated. Uh, so shear force at just left of the point P equals to R1, and the shear force at just right of the equals to minus R2. So after we calculate the reaction force and the shear force, we can easily draw the bending moment diagram and the shear force diagram. So let's program this using Python programming. So in order to do the programming, I will be using this Jupyter notebook. And if you don't know about this Jupyter notebook, and if you haven't installed the Python 8 in your computer, I shall be making a separate video on how to install and how to install the Jupyter notebook in your computer. If you want, please comment down in this video, then I will be making the video in the future. So let's jump into the programming part. So as I showed you earlier, we need to calculate the R1, R2, and for this R1 and R2 we need the value of A and B, and also the load. So let's define the variables. And so initial case, P is the load, capital, let's say it's a capital P is equals to 10 kilonewton. And in Python we add comments by putting this hashtag sign, and let's say this is kilonewton. Then we specify the A and B. A is equals to 1 meter and B equals to 3 meter. So as I said earlier, we need to first calculate the reaction R1 and R2. So let's say R1, and we know that the total length of the beam equals the span of the beam equals to A plus B. Then we need to calculate the reaction force R1 equals to, as I said earlier, R1 equals to B by L into P. So R1 equals to B by L, let's put a bracket here, into P. Similarly, R2 equals to A by L into P. Now what we know is, now we can calculate simply calculate the bending moment. So B bending moment equals to, let's say bending moment as, let's represent it with letter M. M is equals to R1 times A. Then we have calculated the bending moment. Similarly, we should calculate the shear force at just left and just right side of the point load. and we can calculate that as shear force at left equals to R1. Similarly, shear force at right equals to minus R2. So these are the value, and we can print it. We can see the value by printing it. We can use the print statement: print moment, comma shear force at left, comma shear force at right. So if we hit control plus enter in this cell, then we get the value. So the moment here is 7.5 kilonewton meter bending moment, and the shear force at just left side of the point load is 7.5 kilonewton, and similarly shear force at just right of the point load is minus 2.5 kilonewton. So we have got the value of the forces induced in the beam. Now let's try to draw the bending moment diagram. So in order to draw the bending moment diagram, we need 3 points. So if this is the bending moment diagram of any beam, then we need 3 points to plot this. First point is this, second point is this, and third point is this. How the Python works is we need to specify the points that we need to plot, then it just connects line between the points. So we need to identify the coordinates of the points in the initial case. In this case, the coordinates of the point will be, let's say this is x1, y1, then the x1 will be the position along the span of the beam, and y1 will be the bending moment values. So we get the coordinates of all the points. This is x2, y2, and this is x3, y3. But something different in the Python is that we need to get a list of x values and also a list of y values. Then we need to pass it to the plot command. So we need to get a list of x1, x1, x2, x3. Similarly, we need to get list of y1, y2, y3, and we need to pass this value to the plot command. So let's see how we will be doing this. So we know that so in this case we know that we have this beam here. So we know that x1 is the a, x2 x1 is the 0 position, x2 is this a position, and x3 is the a plus b position. So we can just create new cell, and let's say the x1 equals to 0, similarly x2 equals to a, and x3 equals to L, or also we can write a plus b, right? And we also know that y1 is 0, that is the bending moment at the left end is 0. Similarly, y2 equals to the maximum bending moment on the point load. The y2 is the moment that we just calculated earlier, and y3 m is this moment that we calculated earlier. It is the 7.5 kilonewton meter, and again y3 is equals to 0, and that is the moment at the right end is also 0. So in order to plot this, we need to import a library which is known as matplotlib. That is import. We can import it using this command: import matplotlib.py as BMD. Now, in order to plot, we can use this plot function, plt.plot, and we need to pass in the x coordinates and the y coordinates, but we haven't defined the x and y till now. So x would be a list of the x coordinates. So x equals to list of x1, x2, x3 that we have calculated above. Similarly, y will be the list of y coordinates, so that will be y1, y2, y3. So we need to pass these two, this x and y value, to this plot. So let's try to run it. What will you get? So we have successfully drawn the bending moment diagram of this, and I guess it's not looking nice. So we can again fill this bending moment diagram using the plt dot fill between x, y. So we have successfully drawn the bending moment diagram of this simply supported beam. So here the maximum value is 7.5 kilonewton meter. Similarly, let's try to draw the shear force diagram as well. shear force diagram is little trickier, but it's not complicated yet. And in order to draw the shear force diagram, we need more than 3 points. So if this is the shear force diagram, we need this point. Similarly, we need this point. Similarly, we need this point. We need this point, this point, and this point. Thus, we need total of 6 points in to draw this shear force diagram. So what we know this is that the value of shear force at here and here is same. Similarly, the value of shear force at here and here is same. So there's no problem in it. Just the difference is this: in the same position there is a multiple shear force values that we need to plot. So that we need to remember. So in this video we just try to simply declare the variables for each points, but in future videos we will try to incorporate different arrays and try to draw this bending moment diagram. So if we need to simply draw this shear force diagram, what we can do is we need to identify the 6 points. So in order to identify these 6 points, let's define x1. X1 is, let's say this is x1, and similarly this is x2, x3, x4, x5, and x6. So what we know is x1 equals to 0. Similarly x2 is also 0. x3 is equals to the a point, a length. X4 equals to also a length, and x5 equals to a plus b, and similarly x6 is equals to a plus b. Similarly, we need to assign the bending moment values as well. So the y1 is 0, and y2, that is y2 is this point. So this value will be same as this value, and this value is what? This is shear force at left side. So we can do is equals to y2 is equals to shear force at left side, that we have already this shear force left we already calculated here. So and y3 equals to shear force at right side, and then y4, y3 will also be shear force at left side, because y3 is this point, y3 is this point. This is also shear force at left, this is also shear force at left, but this y4 is shear force at right side. So y4 equals to shear force at right side, and y5 will also be equals to shear force at right side, and finally y6 will be 0. Now we need to create a list of these all variables. So x equals to x1 comma x2 x3 comma x6. Similarly, we can copy paste this and just replace the x with y. Finally, we can plot this. Well, we have already imported this plt function here, so we can plt dot plot. We can call this function from here, x comma y, and let's run it by pressing Ctrl+ Enter. And so I guess we have missed something, that is y5 here. In both cases we missed this x5 variable and y5 variable. So x5 comma y5. So let's plot this. Now we get the shear force here, and similar to above, we can just fill between the x comma y. So just we have finally got our shear force diagram here. So in our future videos we will be talking about how we can label this shear force values here, and make this aesthetically more pleasing and more easier to understand. But for this video, this is just the beginning of the course. So I'm just talking about the simple syntax here. So we will be further discussing about this in the future. So if you like the video, please like and subscribe to my channel, and press the bell icon to get the notification of the future videos. Thank you.